Okay, we're on section 1.7, inverse trig functions. Now, if I say inverse functions, inverse trig functions, you would probably know what that means because we've done that when we're doing what? What is an inverse trig function? What are we trying to find? The angles. So basically today is all about finding angles. Now in our geometry, we found angles in degrees. In trig, we're going to find the angles in radians. And the chart will be a really big help to you today. So I've got the chart in front of me. Sorry for people watching the video. If you have your chart, grab your chart. The first half of your homework, page 197, is all going to be just looking at your chart. These should take you about 2 minutes to finish. The last half of these on your homework will just be plug them into a calculator. That should take you about 2 to 3 minutes to finish. You should probably have the first page done in 5 minutes. The 8 through 18 graphs, you'll have plenty of time to do those in class if you work on them, and you can get help if you need help. I just want to review those because tomorrow you'll have a few on your quiz. I wanted you to be able to remember how to graph them. All right, take a look at the chart, and the very first part here says for sine and tangent, we're going to use this interval on our chart. When we're looking for an angle, we're going to use the interval of negative pi over 2 to positive pi over 2. We're going to use that interval. So we're going to look at your chart here, and we're going to color it a little bit today, or highlight it, or outline it. On the sine and the tangent columns, you're going to want to highlight or outline the first 5 boxes and the bottom 5 boxes. On the sine and the tangent columns. The first 5 and the bottom 5. And on the tangent, the first 5 and the bottom 5. So if you have a highlighter or if you have just a regular pen, you can just outline them on your chart. The top 5 and the bottom 5 in the sine column and in the tangent column. Top 5 and bottom 5. Cosine is going to be the top 9. And that is going to be the interval between 0 and pi for cosine. Cosine, we're going to be using 0 to pi for our interval. So to recap, your sine column, you're going to shade in the top 5 and the bottom 5. Tangent column, the top 5 and the bottom 5. For the cosine column, you're going to shade in the top 9. Cosine will be the top 9. Sine is top 5 and bottom 5. Tangent, top 5 and bottom 5. And cosine is the top 9. Not anything on the bottom on cosine. Cosine is just the top 9. Shading those in. So those are going to be the ones that you're going to highlight. I wrote it here, highlight them on your chart. So that's what we're doing right now, just because when we're looking for our answers tonight, the angles that we need to find, we're going to look in the highlighted areas. And I'll show you why as we move down. Now on your chart, at the bottom, I'm going to write a couple of things here because we're going to add something else to your chart as well. So let me write these down. 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi. Okay, so these radians are at the bottom of your chart. You know where you colored it in down here at the bottom? These are the radians that you colored in. On the sine column, you look at those next to it, and that's what they are. All right, so on your chart, you're going to add a couple of things next to the radians, or add one thing next to the radian. Next to 3 pi over 2, I want you to add in a negative pi over 2. Okay, it's on your chart. It's right next to 3 pi over 2. Right next to it, you're going to put negative pi over 2. Because 3 pi over 2 is the same angle as negative pi over 2. One of them would go positive to this 3 pi over 2, The other one would just go negative to the pi over 2. It would be in the same position. These are coterminal angles right here. If you had a unit circle in front of you, 3 pi over 2, here's your 0. Here is 3 pi over 2. If you go this way, you'll get to 3 pi over 2. If you come this direction, it's negative pi over 2, but it's the exact same place. So 3 pi over 2 is negative pi over 2. At the same angle, they're coterminal. One goes one direction, one goes the other direction. 5 pi over 3 is the same as negative pi over 3. It's just going the opposite direction. So add negative pi over 3 next to the 5 pi over 3 on your chart. 7 pi over 4 is the same as negative pi over 4. So there's the same angle on your chart. This 7 pi over 4 is the same as negative pi over 4. 11 pi over 6 is the same as negative pi over 6. That's the same angle on your chart, so write that next to it. And 2 pi is the same as 0 radians. So 0 and 2 pi are the same.
That's a 0.
That's a 0, yeah.
Okay, sorry.
Messed it up a little. Let's fix it so it looks better. All right, so 2 pi would be 0. All right, this right here is important. It says inverse functions may be written as, and here's a new term, arc sine, and that's the same as inverse sine. So in trig, a lot of times you'll hear them say arc sine instead of inverse sine. They won't use the -1. They'll just put the arc in front of the sine. It means the same thing. Still means you're finding an angle. It probably means you're finding a radian angle rather than a degree angle. More often than not, you see the arc sine, you're going to be looking for degree or radians. You see sine -1, you might be looking for degrees, but they still might be looking for radians. In today's homework and stuff, you're going to be keeping all radians. So since we're in our trig, we're going to use all radian angles today. But you could write it either direction. They mean the exact same thing. So if you have one that says sine -1 right here in letter B, it could be written as arc sine. Same thing. So here's what we want to do. We're going to look at example 1. Look at your chart. Go down the sine column on your chart and find out where the -1/2 is on the sine column. Where is -1/2? Okay, there's a -1/2 at 210, which is 7 pi over 6. There's also a -1/2 at 330, which is 11 pi over 6, or negative pi over 6. Which one would we want to use? We want to use the one that's shaded in. We want to use the one that's between this interval right here, which for us, our answer to this would be negative pi over 6. Or we could put negative 30 degrees. Because pi over 2 is like 90 degrees, and negative pi over 2 is like negative 90 degrees. So we could have, if we were using degree angles, our answer would be negative 30 degrees. However, in this section, we're going to be using radian angles. So that would be the answer we're looking for, negative 5 or 6. So look at your chart. You see where it was -1/2 down here at the bottom? You look over, and it was 11 pi over 6, which is negative 5 or 6 radians. So your answers are right on your chart. How come I didn't use that one? Because it's not in the shaded area. The shaded area is the interval that we want. If it's not in the shaded area, it's not the answer you want. You want the one in the shaded area. This right here is 11 pi over 6, which was negative pi over 6. 7 pi over 4, which is negative pi over 4. Yes. Well, I just converted this. 180 divided by 6 was 30 degrees. So it could be either one, but these are both the same. This one's radians, and this one's degrees. Now, the answers in today's homework will all be radians. So I'm just showing you that you could have either degrees or radians. In the sine column, as you go down the sine column, where is radical 3 over 2 in the sine column? Find it in the shaded area. Radical 3 over 2. Okay, we're not looking for degrees, we're looking for radians. Pi over 3 radians. So here's your answer. For this one, be pi over 3 radians. So they're going to go fast. Once you find them on your chart, you have your answer right there. Go down the column for sine and see where the sine is a 2. Look in your shaded area. Where is the sine of 2? It isn't. That's 2, is it? Sine can never be greater than 1. So if it says inverse sine of 2, that means in your calculator it would say domain error. Which for us means no solution. There is no angle. There's no angle. You could put undefined. You could put no solution. You could put error if you wanted to. It's just not, there's no sine of 2. Remember, the hypotenuse is on the bottom. So it's got to be 1 or less. It can't be more than 1. The biggest number is on the bottom of the fraction. It can't be more than 1. So sine of 2 is not going to ever happen. Okay, so those are the examples for the sine column. Let's do some cosine and tangent columns, but that's on the next slide. So I'll give you a second to make sure you have that down. Okay, let's try arc cosine of radical 2 over 2. Where is the arc cosine of radical 2 over 2 in our shaded area? What radians? Pi over 4, because we're going to be getting our answers in radians today. So pi over 4 radians. Where is the cosine a negative 1? You go down to the cosine column, negative 1 at pi radians. Yep. This would be pi radians. Arctan of 0. What angle would make the tangent of 0? 0 would. Or 2 pi would. But we want the interval between pi and negative pi, so it's got to be 0. So you would put 0 radians. Inverse tangent of negative 1 on your chart. Inverse tangent of negative 1. What would it be? So we don't want the 7 pi over 4. That's outside of our interval. We want the negative. What is it? Negative, not negative 7. Just negative pi over 4. Yeah, it's negative pi over 4 radians. That would be where the tangent would be a negative 1, and it would be in our interval. Our interval is between pi over 2 and negative pi over 2, and this would be inside of that interval. So that would be the angle we're looking for there. That was 4 problems that we just did in a minute, about a minute or two's time. That's why you're doing on the 1 through 15 today. You're just finding them on your chart and writing down the radians. Now the last half of the first page is that you're just plugging them into a calculator. So if you have a calculator, use it. If you don't have one, wait till we start and you can come grab one. Let me just show you what this would look like here. Now arctan, how would I put arctan in my calculator? The tan negative 1. I'm still doing the negative 1. It's the same thing. Arctan and negative 1 are the same. So I'm going to go to my calculator, and what mode do I need to be in today? Radians. All of them are going to be radian mode. So grab radian mode and put in inverse tan, and then put in negative 8.45. And you're going to get a negative 1.453. Negative 1.453. See if you get that to come out of your calculator. No, you just plug it in like this. Hit the DRG button. Oh, there's a C right next to Maria right there. Okay, so you should get the negative 1.453 radian. That would be what you get there. Probably about a negative 70 degrees or so, because 1 radian is 57 degrees. So 1.4 is another 20, 25 degrees. So somewhere around 75 degrees negative. But we're in radian mode, so we want to be radians. Let's try this one. Inverse sine of 0.2447. And you would be at 0.2472. 0.2472. So make sure that comes out on your calculator. Let's practice. We'll see if that can come out on your calculator. Just keeping radian mode. That's like I said, this whole last section right here, 19 to 31 on. It's actually supposed to be 33, sorry. But they're just calculator ones, so it's not like that's gonna take you a whole lot of time. Is to just plug it in and see what you get on your calculator. You should have the right radians. Arc cosine of 2. So I would put inverse cosine and I put in 2, and it says domain error. Which means what? There's no solution, right? You can't have a cosine of 2. Cosine can't be more than 1, just like sine can't be more than 1. Because the hypotenuse, again, is on the bottom, so we don't have any solution for that. There is no error. It's an error. It's an undefined. It's whatever you want to write it as. There's no solution for that. Can't have a cosine of 2. There's just 2 small examples left. So I want to make sure you have that down real quick, and then I'm going to move it to the last 2. They're just 2 triangles, 2 little right triangles. Then I want to show you how we could set up an inverse trig function. We're not actually even going to solve them. We're just going to set them up. So see how we would find the angle on the last 2 triangles. Move it. We good? Okay, so you've got 2 triangles, and you've got an angle theta right here. And all it says is use an inverse trig function to write it as a function of x. Doesn't mean solve it. Just give me an expression that I would plug into my calculator if I knew what x was. And it says, since it's theta, I know that my answer is probably going to be in radians. Because if it was x or y, we would probably have degrees. Theta is usually going to be a radian measure. Now, what trig function would we need to find the angle in that first one? Which one? Got to be tangent, because you've got your opposite side and your adjacent side. So you got to use TOA, but I would use arctan, because I know it's going to be in radians, and so I might as well just put arctan so I know that I want my answer in radians. Arctan, and what's my fraction going to be? X over 4, and that would be your answer. They don't need you to solve it. They just want you to write it as an expression. So arctan of x over 4. How would I do the second one? I got opposite, and I got hypotenuse. So what are we looking at with OH? So, right, so what am I looking at here? Sine, but I want arc sine because I want the angle. Arc sine of what? X plus 2 on top, let's put that in parentheses, divided by 5. And that is your answer there. And that's all for 1.7. Now, like I said, it's probably one of the shorter sections that we have, and the problems aren't going to take you very long. The ones that I do want you to really work on and ask me questions on if you get stuck are the graphs. Because you'll have a few graphs on tomorrow's quiz, and I want to make sure you know how to do those. So the first ones won't take you very long. On the graphs you can review.